In this session, I am sharing a battery level monitoring circuit. Using this circuit, we can monitor 12 volt, 24 volt, 48 volt, any voltage value. Either it is power supply, either it is battery. When voltage are less than 10 volt, all LEDs are off. That means the battery is near to end limit. When battery will obtain 10 volt, first LED will turn on. When voltage will reach at 16 volt, the second LED. We can see the voltage value here and LED response. At approximately 21.5, third LED. Yes, last LED at 28 volt. I adjusted this circuit to monitor 24 volt battery and maximum level is 28 volt. But we can adjust our required values using these potentiometers for each operational amplifier. I used LM324 IC. When voltage are above than 28 volt, last section is also indicating that battery is full. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. If you are new to my channel, you are invited to subscribe it. And if you think this video is informative, then you can share with your friends and like this video. Let's start. Let's make battery monitoring circuit using LM324 operational amplifier IC. There are many options to monitor the battery. We can use LM339, LM393 or any other comparator, but this time I am using operational amplifier as a comparator. In my last video I demonstrated how to test LM324 IC. We will use this IC to compare the voltage and we will display different levels of the battery on 4 LEDs because in this IC we have 4 sections. We will display 4 levels of the battery. Let's suppose if I am trying to monitor 12 volt battery, we can set a minimum level, mid level, upper mid level and highest level like 7 volt, 9 volt, 11 volt, 14.5 volt. If you are using 24 volt battery, 10 volt, 15, 20, 26. I am using scaling method to the battery voltage and we will provide variable reference to the reference pin. In any comparator or in any operational amplifier, we have a known reference and we will compare this value, that is variable value, from any sensor, from any battery level, from anything. We will compare this value with this reference. Using scaling method, we will use any voltage value, that is from any power supply, any battery whatsoever. We will apply to a voltage divider network. We will connect 2 resistors. Let's suppose I want to sense 28 volt, 26 volt, maximum 28 volt. Because when it is charging, the battery will reach up to 28 volts. In case of 24 volt battery, if we are using 12 volt battery, that will approximately 14.3 volt, 14.5 volt. We want to divide these voltage when the battery level will change from minimum to maximum or maximum to minimum. We will receive variable output at this point. It is R2, it is R1. Less than 1 milliampere, let's suppose 0.5 milliampere, that's also good. 28 divided by 0.005, okay, 56K. We need RT, total resistance in this channel, 56K. If I use a standard resistor 10 kilo ohm and 47 kilo ohm, it will around 57. So that will approximately close to this value, so it will not dissipate too much power. Let's suppose we have 28 volts. We will use voltage divider formula to take output at this point. VR2, R2, R1 plus R2, V battery. We will use different values of the battery to monitor the voltage here. Let's suppose R2 is 10K divided by 10 plus 47 multiply with 28 volt. At 28 volt we will receive 4.9 volts. When battery is full, 28 volts, output at this point will 4.91 volts. If voltage are, let's suppose, 22 volts, we can set any required value. It is 3.85. If we have voltage 16 volts, that time this point will add 2.80 volts. Let's suppose minimum level 10 volts, we will receive 1.75 volts. So it is scaling method. At different voltage values we will receive these voltage. To make any non-inverting comparator, we will use LM324 IC. This is non-inverting input. There is positive sign, and we have inverting input. We will feed this signal to non-inverting input. Inverting input will be connected to a reference. We will adjust this reference as per our requirements. We will apply 12 volt to this IC. 12 volt positive at pin number 4. 11 is common ground. We will use a potentiometer 10 kilo ohm. One side grounded, second side positive 12 volt. This is one section. If we are using one channel, because this is 4-channel IC, channel number 1 or operational amplifier number 1, non-inverting input at pin number 3, inverting input at pin number 2, output from pin number 1. If we are using second channel, operational amplifier number 2, pin number 5, non-inverting, pin number 6, inverting, pin number 7, output. Channel number 3, pin number 10, non-inverting, pin number 9, inverting, pin number 8, output. Channel 4, pin number 12, non-inverting, pin number 13, inverting, pin number 14 is output. Sometimes we see NI, non-inverting, we will see positive sign here. Inverting input, negative sign. That is not power supply, that is identification for inverting or non-inverting inputs. Let's suppose I want to monitor first channel. In that case, pin 1 is output. Pin 2, inverting, that means this is pin 2. Here pin 3, here pin 3. Same configuration, same pin will be routed to all operational amplifier, pin number 3, pin number 5, pin number 10, pin number 12. We will use 4 potentiometers. Each potentiometer will provide its reference. Let's suppose first channel will monitor 10 volts. This potentiometer will provide 1.75 here. When voltage will drop up to 10 volt, this pin will receive this voltage. That time it will provide output. To make a smoothly working comparator, it is best way to use positive feedback resistor between non-inverting input and output. You can connect it. If you don't connect, it will also work fine. But to make it extremely stable, 1 mega ohm, 500 kilo ohm, 1 mega ohm, up to 2.2 mega ohm, that's fine. 1 mega ohm is preferred. We will see its response now. Let's make this circuit. I will use 12 volt power supply, common here, positive here. This power supply is to power up this IC. Pin 4 positive. Pin number 4 positive 12 volt. Pin number 11 ground. To monitor the output on LED, I will use 10 kilo ohm resistor on each output. One LED, it will be grounded. 10k resistor is fine when we are using 12 volt power supply. So it will draw around 1 milliampere or less than 1 milliampere. So that's fine. I am using 3 millimeter LED. Otherwise we will need a driver transistor to amplify the signal. LED short lead, small lead to the ground pin. We will connect a resistor here. We will connect to pin number 1. Pin number 1, resistor, anode, cathode. Now we will see the result. When we have 10 volt, the scaled output here is 1.74 volt. Same this one. We will decrease it now less than this level. Let's suppose battery is approximately 9 volts. That time we have scaled output 1.5 volt. We will feed this input to pin number 3, that is non-inverting inputs. Non-inverting inputs are our sense signals. Now we need a reference signal. To make a reference signal, we will use potentiometer. 10 kilo ohm potentiometer, the same, one side connected to positive supply, second side of this potentiometer to ground level, and here we will adjust 1.75 volt. We have 0 volts. We will adjust this potentiometer to make 1.75 volt. It's great. I am using multi-turn potentiometer. Now I will feed this signal to pin number 2. At pin number 2, we have 1.748 volt, and this time battery voltage 9 volt and sense signal is 1.5 volt. Now I will increase battery voltage. Let's suppose battery is charging now. This pin will now increase. When we will receive 10 volt, scaled output here will around this level. At this level, here is flashing. To overcome this issue, intermittent condition, we need a positive feedback. If we don't use positive feedback resistor at that specific level, that is offset value, sometime it will turn on, sometime it will turn off. So best way to use 1 mega ohm resistor, as I discussed here, between pin number 1 and pin number 3. Now when voltage level will be obtained properly, the LED will turn on. This time there is no flickering. It is effect of 1 mega ohm feedback resistor. This is pin number 2, this is pin number 3. At pin number 2 we connected a potentiometer between positive voltage and ground, so it is our reference signal. We adjusted this potentiometer at this level. Next operational amplifier, pin number 5, 6, 7. We will use another LED, 10K resistor at pin number 7. Same way we will use the same scaled signal, this signal, that is input signal. Now it will reach to non-inverting input pin number 5. Pin number 6, same other potentiometer, 12 volt and one side grounded, 10K resistor, LED. So this is pin number 7. We will connect pin number 3 to pin number 5. And we will use another potentiometer, this one to positive side, positive 12 volt, potentiometer second side to the return path, common line. Here we will adjust 2.8 volts. Okay, great. Now we will connect this pin to pin number 6. When battery voltage will reach at 16 volt, second LED will turn on. "11, 12, 13, 14, 15 and yes, at 16 volt the second LED is turned on. Now we will feed the same sense signal that we connected pin number 3, 5. Same signal will reach to next operational amplifier. 7 output, 5 non-inverting, 6 inverting, same here, 8 output, LED and resistor, 9 potentiometer, and we will connect same pin number 5 to pin number 10. Pin number 9 potentiometer. One side potentiometer positive side, second to the return path. I don't have more 1 mega ohm resistor, so I connected 1. At each comparator we need to connect a resistor between output and the sense line. So that will create a smooth switching. We will adjust this one approximately 3.8 volts so that 22 volt will indicated on LED. 3.8 volts. Okay, 3.7 is nice. LED, ground, 10K resistor, resistor second side will be connected to pin number 8, and we will connect this potentiometer at pin number 9. Pin number 10 will be connected to pin number 3 and 5. This is 5. It will reach to pin number 10. This LED turned on at 10 volt. This at 16 volt. Now I will increase the battery voltage. When we will receive approximately 21 volt to 22 volt, third LED will turn on. Yes, at 21.7 volts the LED turned on because I adjusted slightly below the limit. So that's good. Now we will connect fourth section. Fourth section is connected to pin number 14. Here is pin number 14. Output at pin number 14. Inverting input potentiometer at pin number 13. 14 out, 13 potentiometer, and 12 sense signal. The same 10 will be connected to pin number 12, 10, 5 and 3 are connected together at the same sense line here. Sense line at pin number 12. Same way, this potentiometer 1 end positive line, second end to the common. Potentiometer will be connected to pin number 13. Three LEDs are turned on, that means the battery level is above 10 volt, above 16 volt, above 22 volt, but less than 28 volt. It is not full. Now the battery is charging and its level is increasing. We want to adjust the last reference at 4.91 volts. 4. Yes, it's good. This reference pin will be connected at pin number 13. Now when voltage are increasing, fantastic. At 28 volts, the last LED is also turned on. So our circuit is working nice. When we have 28 volt, all 4 LEDs are indicating that battery level is at maximum. We can adjust the potentiometer as per our requirement. When the voltage are less than 28 volt, the last LED is now turned off. Voltage are dropping 26 volts, around 22 volt, less than 22 volt, this LED will turn off. Yes, 21 volt LED is off now. Next LED around 16 volts. When the battery is discharging and it will reach at 16 volt, the next LED will turn off. Yes, 15.7, 15.8, the LED is shifting the level. When the voltage will drop less than 10 volt, the last LED will also turn off. Yes, 9.8 volt LED is off. When battery will obtain 10 volts, first LED on. At 16 volt, second LED. Perfect. 22 volt, third LED. If you have not subscribed my channel until now, subscribe it. At 21.8 volt, the LED is turned on. We can adjust a minor adjustment using these potentiometers to set our required reference. Each section has its own potentiometer. This one for last section, pin number 9 is second last. First at pin number 2, that is this one, second, third and fourth. When voltage will increase at 28 volt, the last section will also turn on. Yes. In upcoming session, we will use a fixed reference and we will adjust different trigger points as final words. A comparator is a circuit, is a function which compares a reference value with any variable signal. We created variable signal. This is V battery. (47 kilo ohm), 10 kilo ohm. Here our test signal. We have 4 operational amplifiers. Positive, negative, non-inverting, inverting, non-inverting, inverting, non-inverting, inverting. At each section we have 10 kilo ohm resistor and LED. Pin number 4, positive 12 volts. Pin number 11, ground. We connected potentiometer between ground and positive. 10 kilo ohm potentiometer. One potentiometer, second potentiometer, also connected to positive side, one end. Here 10 kilo ohm. We connected test signal pin number 3, pin number 5, pin number 10 and pin number 12. This reference signal at pin number 13, this reference signal at pin number 9, reference signal at pin number 6 and 2. Pin 1 output, pin 7 output, pin 8 output, pin 14 output. At each output section and non-inverting input, we will connect 1 mega ohm resistor. So it will protect the circuit from intermittent switching of the LEDs, because in operational amplifier or in comparator there is a minor offset that is in few millivolt, 100 millivolt, 200 millivolt, that will cause an intermittent display on the LEDs. To make a smooth switching, it is best way to connect a capacitor 1 microfarad, 16 volt, 25 volt, 50 volt, 25 volt is good. So it will protect the circuit from false switching, from ripples across this low side resistor. I connected capacitor across this 10K resistor. If you think this video is informative, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.